So today we have a webinar on the really cool work that C2SMART has done on the COVID-19 transportation data dashboard. This interactive data dashboard found on the C2SMART website consolidates several public data sources to track the impact of the pandemic as it unfolds on the different transportation systems. So to walk us through the dashboard, I'd like to introduce my colleagues, Dr. Jingqin Gao, a research associate here at C2SMART. She's completed her Ph.D. in transportation planning and engineering here at NYU, where she works with C2SMART Director Kaan Ozbay on various research projects. Her research interests lie in offline and real-time simulation modeling, big data and machine learning approaches to transportation, and transportation economics. Her co-presenter is Yubin Shen, who developed and maintains the data dashboard. He's a research engineer at C2SMART and previously worked for MTA City Transit. His research interests include database optimization, web data crawling, and embedded systems. Today's webinar is Developing C2SMART's Interactive Data Dashboard, COVID-19 and Transportation. Dr. Gao, please take it away.
Thank you, John. Hi, everyone. I'm Jingqin Gao. You can also call me Jannie. And today, Yubin and I are going to introduce, how we develop an interactive data dashboard to understand the impact of COVID-19 on transportation system. So first of all, I want to say that this is actually a collaborative work between multiple universities, including New York University, University of Washington, and Rutgers. So you'll be able to see the team members over here. I want to actually thank to all of the students and professors who help us, contributing to the data collection and also data automation for the dashboard. So for today's presentation, I'm going to first give an introduction of the data dashboard. And then I'm going to highlight some of the findings, some of the recent findings towards the new normal that we observe on the data that presented on our data dashboard. And then you've been going to introduce the backend architecture of the dashboard and also how we achieve the data automation. And in the end, I'm going to show a quick live demo of some of the functionalities of our dashboard. All right. So the motivation of building this dashboard is pretty straightforward. It is because, the pandemic has dramatically changed the travel patterns. And we found that there's actually a need for us to build an all-in-one dashboard that pulling different, like multiple data sources, especially the open data, to help us to monitor transportation trends in the wake of COVID-19. And we believe this is the only developed and on-site, an open site that integrated all these kind of data sets in one place, as far as we know. So basically, our data dashboard covers travel trend and mode choice. And besides this mobility part, we also have the sociability portion, which we measure the effect of social distancing. And we're not only doing that for New York City, but also have information from Chicago, from Seattle, and also 6 cities in China. The reason why we're including these Chinese cities is because China is basically ahead of us in terms of the pandemic, and we would like to know, how their system restoration looks like, in their especially in their subway system, and this will also provide some of the insights for us to see, how the recovery is going to look like in New York City as well. So here we listed some of the data set that we're collecting right now. Of course, including transit riderships, like bus ridership, subway ridership, commuter rail. We also have vehicle traffic information, volume, speed maps, and also corridor travel time that we extracted from our virtual sensors. Besides that, we also collecting record-based data such as speeding tickets, NYPD reported crashes. In addition, we produce some of the spatial maps for city bike trips and taxis. And we also, one of the important portion over here is the social distancing measurements. So what we did is we actually we developed a deep learning based on computer vision algorithm. And so based on that, we can do object detection based on the information that we grab from the public available open source, traffic camera that are already installed in the city. And the last one is the weighing motion station. So this is a part of our C2SMART test bed that we installed the weighing motion stations on BQE. And it not only provides us like traffic volume, speed information for the general traffic, but we also have that information for the freight traffic, especially divided by vehicle weight classes. So this slide's just trying to present where we are now in July and August 2020 compared with 2019 for New York City. And as you can see from the upper right corner, the graph over here showing you the trend starting from March 1st of like how MTA bridge and terminal vehicle traffic looks like, how accessory ride, commuter rail, including Metro North and LIRR, and also like bus ridership and subway ridership looks like. So basically, this NYC data is showing that car and freight volume, they almost have fully recovered to the pre-pandemic level. And this is also indicating a potential mode shift to buses and other non-public mode of travel, such as micromobility like city bike. So as you see over here on the right bottom, which is the ridership of the city bike trends. And if we see the data in July, city bike trips are up 71% up compared with February 2020. And our dashboard mainly contains two subboards. One is called mobility board. The other one is called sociability board. So I'm going to start introducing some of the findings that we got from the mobility board. So first of all, recently what we observe is there is an uneven increase in the vehicle mile traveled, VMT. And this rebound in VMT is different across New York City from different areas. For example, here, you see Manhattan, Brooklyn, Bronx, and Staten Island. All four boroughs, we see an increase in VMT in August compared with February 2020. However, Queens is still a negative number, is still minus 18%, which is showing that Queens has a slower rebound in terms of VMT. And then we say that maybe we want to take a closer look of how this interborough traffic actually happens, and how does the trip looks like from Manhattan to Queens or Queens to Brooklyn. And that's why we build this type of like OD matrix, origin destination matrix on the right. And on the right top, as you see here, we're comparing April 2020 this year and compared with April 2019. So basically, this is showing how the traffic looks like, the interborough traffic looks like during the pandemic. And then we also create another table, which is showing July 2020 versus April 2019. So this is basically showing you like how the recovery looks like. And we found that by July, interborough traffic has almost seen a nearly full recovery from April lows, except the trips originating and destinating at Manhattan, which saw a much slower rebound. You see these like red color cells. And the other thing that we found is this traffic between Brooklyn and Bronx, which is the blue ones over here, has increased by 41%, 43% from pre-pandemic levels. So we say, besides the general traffic, what about the freight traffic? And then we create this table for freight traffic as well. And our interest is, to know if the freight traffic has the same pattern or maybe not. And actually the answer is no, they're not having the same pattern. And from the freight traffic matrix, what we observe is an earlier rebound was found for both inbound and outbound traffic in Staten Island. And thinking about the possible rationale behind that, I think that's possibly due to the increase, home delivery demand, online delivery demand, from the Amazon Fulfillment Center, which is built in Staten Island. Of course, like further observation is needed when more data is available, but this is kind of like preliminary results that we found. And the other thing that we're kind of interested in is we know that taxi and for-hire vehicle industry are getting hardly hit by the pandemic, but we don't know like how bad it is. And TLC recently just released the first half year of the data for both taxis, for-hire vehicles, and also Uber Lyft. So based on that data, we create all these charts and tables. These are all available in our data dashboard to see how the trend goes. And yes, all like including yellow taxi, green taxi, and for hire vehicle, which generally include black cars and community cars, and high volume for hire services, HVFHS. This one include Uber, Lyft, and Via usage. And we saw a really low number in April. And if you see over here for this row, yellow taxi was 96% down compared to last year. Green taxi is minus 92%. For Uber, Lyft, and Veer is minus 79%. For high vehicles is minus 76%. And these numbers start to gradually rebounded in May and June, but they are still very low. As of June, we still see like 60% and 90% lower than those at January 2020. So besides just the trip numbers, we're also interested in see, does the trip pattern also change? Are people taking longer trips, or are they afraid of riding together on the shared mobility or on Uber or Lyft? And that's why we create these 3 additional charts, which is the trip distance, trip duration, and passenger count. So we extract those numbers from the taxi trip records, and we found that yes, the average distance of a completed ride has increased during the pandemic. If you look at the yellow taxi number over here in February, the average trip distance is 2.4 miles. And this number doubled in May, which goes to 4.8. And all these numbers kind of like, gradually goes down and goes back to the pre-pandemic level starting from June. Trip duration has the same trend. Passenger count, especially for the green taxi, you see that's dropping from 3.4 passengers, average passenger count per taxi to 1.4 during April. So of course, this is also because of the instruction from the government that passengers are suggested not to sit beside the driver, and they're suggested just not to ride in a group. But we think these numbers kind of give a really direct insight of how the taxi trips looks like, how the patterns and how the behavior of people are changing through the months. And the other important finding actually is a surge in speeding, and we think this might kind of remain as one of the new normal happening in the aftermath of the COVID-19. So basically the data from the speed cameras violations, and these are all like school zone speeding tickets, are skyrocketed during the pandemic. And if we look at the numbers itself, the daily school zone speeding ticket were up 70%. In July compared to the pre-pandemic, from January to March. We're not comparing with 2019 because 2019 we have less cameras, and also the enforcement period is shorter in 2019. But just compare with pre-pandemic in 2020, this number increased a lot. And we also plot the temporary distribution of the speeding ticket and find out that 2 p.m. to 6 p.m. probably is the worst period that drivers are taking advantage of, maybe like less traffic on the road, and these are the period that they usually speeding. Okay, so another question comes into when we look at this data, when we present it on our dashboard, is that, is it just drivers like randomly getting speeding tickets, or there are actually maybe a small amount of drivers, they are the one who's repeatedly having the speeding behavior, and they are the aggressive drivers. So we extract the unique plate IDs, and based on that, we found out, during April, there are about like 30% drivers, they are issued more than 1 speeding ticket, and 5% of them receiving more than 3 tickets. And this is the worst part, that these like 0.2% of the drivers, they probably are the most aggressive drivers on the road, that they receive more than 10 speeding tickets in just a month. Right, and the other intuitive thought is, this might be related to the number of crashes, or this might be related to the fatality. So we're still kind of unclear of the relationship between speeding and crashes. It's a little bit hard to say, but if we look at the fatality numbers, half of the fatalities in April and 42% of the fatalities in May, they are actually due to unsafe speed. So unsafe speed is a specific field that NYPD use in their reporting, and that's usually representing speeding behavior. So yes, there's some relationship, between the fatality and speeding, and this is something that we should really alert. And this is what the dashboard, the data is telling us. We may need to take some actions on this to prevent more speeding behavior. So besides New York City, we also have information. These are like 3 traffic volume locations from key locations in Seattle, including 1 from Lake Washington and 2 from I-5, 1 from downtown Seattle, another one is around like Green Lake Park. And we also have the travel time on Interstate 5. So these two together are kind of providing us some information about, the travel pattern in Seattle. And also, as I said, we also have information from 6 cities in China. And one interesting finding that we saw is after 6 months of full reopening of those cities in China, there's only 85% of the pre-pandemic transit ridership restored. And if there's a second wave of COVID-19 occurred, as you see the blue line over here for Beijing, this restoration will, further go down, and it only reaches 65% of the pre-pandemic level. So although New York City or like other cities in US is not exactly the same as those mega cities in China, but I think this is kind of like providing us some insights of how our system may look like, in 6 months of reopening. And even with that, we know that after half year, we're not getting 100% full restoration of our transit system. And there might be something that can be planned ahead before we even reach to 6 months. Okay, so besides the mobility board, the other important board that we have is called sociability board. And the challenge here is that we know that social distancing orders announced and the social distancing rules or behavior probably will remain for a longer time than we expected from the beginning. And also, the problem is it kind of remains unclear how people, are responding to these policies. It might be a little bit easier for like indoor, enforcement, where we kind of ask people to wear a mask when they're indoor with other people, when they're close to other people, but it's kind of hard to see how people react or respond to this policy in an outdoor environment, especially, for those places which may have some crowd, like corners of the intersection when people waiting for the signal lights, or bus stops on the curb lane, when people are waiting for the buses. So how to, identify the density of these crowds, and also how to understand the actual reduction in social contact, or maybe not even reduction, or how people, keep distance for this, is very important. And motivated by this, we develop a deep learning-based video processing algorithm. And this is using computer vision techniques to measure the social distancing using already installed cameras in the cities. And by doing that, we're able to do like real-time object detection for different classes, including pedestrians, cars, trucks, buses, and cyclists. We also develop a reference-free distance projection and approximation method. So by using that method, we're able to measure or estimate the distance between a pair of pedestrians. And then we can quantify that information to see, if they're like less than 6 feet or not. And besides the general approach, we also say for some of the key locations, where we have some pre-pandemic information, then we are able to actually build this temporal distribution, by time of day, and also like spatial density distribution to see if the behavior are actually different at different locations or at different time of day. So I'm not really going into the details about this part because Guan Zhuo, who will probably provide another webinar on this topic in October, talking about the details of like how we developing this methodology, how we validate our approach, and also about this reference-free, social distancing estimation algorithm. But I want to say that if you look at the picture on the bottom left, so these are the locations of the traffic cameras. We have more than 700 traffic cameras in New York City, and they're open to the public. And what we do is we actually select 105 locations because not all the cameras are facing, like roadway or facing intersection. Some of them may facing the highway or for different usage. So we select 105 locations in New York City, and we also pick one location in Seattle. Unfortunately, that's the only one, which is facing intersection in Seattle. And the location is pretty diverse. We include locations near hospitals, near subway stations, and also the ones near, like meal distribution centers. And this just giving you an example of how the output of this, object detection looks like. These colored bounding boxes are the identified objects, include buses, cars, and pedestrians. And these blue lines between the paths here. So these blue lines only will show up if a pair of pedestrians, their distance is less than 6 feet. Of course, 6 feet, this threshold can be changed. And on the right side, they identify number of objects, and also they identify like, how many pairs of pedestrians are not obeying the social distancing rules as shown on this part. Okay, and next I'm gonna pass this to Yubin, who's gonna give us introduction of the whole architecture of our data dashboard and also how the backend looks like. And he's gonna also talk about the data automation, like how we achieve to doing that from different sources that we're collecting. Yubin.
Okay, thank you, Jannie. So let's talk about the basic architecture for the whole dashboard. So as you can see here, so we separate them, the procedure into 3 different parts. So the first part is about how we get the data, how we get the raw data. So actually we have several resources. So we can we collect them from the both from the public portal like the NYC Open Data or NY511, or have from some companies' web page, or we can collect them from other research center or other organization. So that's the first step. We extract the data, and then we store them into some database, like the SQL database or the non-SQL database. So that's how we collect the data. So after that, we need to do some transform to validate the data and parse the data to make sure that the data is good enough for analysis and for visualization. So we transform the data and pump them into our data warehouse inside our center. And then finally, we got some analyze, and we pop the data into the data dashboard for visualization, also for some video processing like Jannie talked before, or for some other researchers to do their research or do their study about the data. So that's the basic architecture for the data dashboard. So let's move on. So let's talk about the visualization. So we know that a lot of visualization tools is on the market, and they have pros and cons. So how to just find out the most, the most important or the most effective one for our dashboard is important. So I list several performance or several criteria. So let's talk about them one by one. So the first one is about the layout flexibility. That means how responsive the dashboard is for the different type of the devices. For example, the mobile phone or the tablet or the laptop or the desktop or even larger screen devices. And the second one is about the scalability. That means like how the dashboard performance is when the data sets become bigger. For example, does the tool will change the granularity automatically, or they have adjusted the layout if the data become bigger. And the third one is about the data access control. That means like how we can share the data. So if there is any data control, so allow the user to download the data or they cannot download the data. And the fourth one is about the development time. So how many time we need to take for develop some visualizations. And the finally is about the additional technology required and some cost consideration. So I list those criteria and compare those 4 tools like JavaScript, Tableau, Power BI, and Carto. So finally, we choose the Tableau. So we choose Tableau based on several reasons. So for the JavaScript one, like the D3.js library or the DeckGL library, they're pretty good, but they need more development time, and they need the researcher to have some specific technology like the HTML, CSS, and JavaScript, and a lot of any other design things. So that will be very time cost. So for the Power BI, they are good. I mean, but consider 2 reasons. One is the data access control. So according to the Power BI description, so if you want to make the dashboard public, you will have to make the whole data public. So that's something we don't want to see. And other things about they need a license. So the free version, they have a lot of limitations. So they will make the development have some troubles because they touch the limitations. And for the Optical, this is only the location visualization tool. So if your visualization is only about the map or the geography, they are pretty good. But for our dashboard, we have a bar chart, a pie chart, and some tables. We have a lot of other visualization methods. So in that way, the Optical is not the ideal choice. So that's why we choose the Tableau. So the Tableau have a lot of good feature, and they offer the Tableau Public, which is free and very convenient for the user to use because they offer the GUI, so you can just click. So it's easier than the coding or do some script to analyze the data or to pump out the dashboard. So yeah, so let's move on. So let's talk about the data automation. So here, why we think data automation is important? That's because that part is most time cost part for the update. So let's say that if you want to update your dashboard frequently, for example, like once per week or once per month, so the update procedure will be time cost, and they will make they will involve a lot of things you need to check or take care of. So that's why the data automation is important. So there's three basic elements to the data automation. That's called the ETL, so extract, transform, and load. So I will show the method we used for this dashboard later on for the following slides. But the core idea for the data automation is to not do the things overhead. So let's say that you have to consider the dashboard situation. Let's say that your dashboard only consists of maybe 3 panels or 4 panels, so you can just do them manually. However, so if you have a 20 data set or even larger data set, so this procedure becomes complicated. So you need to think about how to optimize that and how to make a data automation. So actually in the production, so we do the hybrid way. So we combine several methods together to maintain the data set and to make sure the performance is good enough. So let's talk them one by one. Okay, the first one is the basic one is we manually update everything. So this graph shows the procedure of how the procedure we update the dashboard. So you can see that we have 5 steps. So we have to get the update data set first, and then we run the script to analyze it. And then we upload, we open the Tableau Public to reload the data. And then we upload the data sheet to the Tableau Public server. And finally, we check the result and to make sure that it is good enough. So it's very, the operation is very heavy, especially when you have let's say that 20 data sets. So it takes about maybe 1 hour or 2 hours or even longer to maintain the whole process. It's kind of very heavy for the people who update the dashboard. So we improve that. So to the semi-automation. So the semi-automation, we do the ET or the TL by scripts. So the ET means we extract and transform the data by the script. So this kind of method applies to the things, to the data, which is the open source data. So we can extract the data by the script, and then we do the analyze. And then after the analyze, if the user do not have the access to the database or to the repository, so we can manually upload the data for them. Or on the other side, so if the data is not open source, so if the data, we need to get the data from some organization or from some research center, So we have to wait until they provide the data, and then we can transform and load the data to the data warehouse or the database. So that's the semi-automation. So also I want to mention that Tableau Public support the data synchronization from the Google spreadsheet, which will save one step for the things. We do not need to open the Tableau Public to reload the data. So we can just pump the data to the Google spreadsheet, and the Tableau Public will get the data from Google spreadsheet automatically. So the frequency is once per day. So I think the frequency is good enough for the general use. So that's the semi-automation. So finally, we go to the full automation. So that means for each data set, so we create a script which contains the whole ETL process, and we execute by week or by month. So in that way, we can warp up all the operations, and we can add error handling process inside the script. So we have a fully control of the whole process, and we can largely reduce the operation time for uploading or updating the data set. So finally, we reduce the things from the 4 step to 2 step. So Jannie, please, yeah. So finally, we do everything by the ETL, by the script. So we do ETL by the script, and we check the dashboard to verify the database, to verify the data and the updates. So that will be the ideal way for the data automation. So we do everything by the script. And finally, I want to mention something about the serverless thing. So serverless thing is about how we can just process the things without the server. So I give 2 examples here. So one is for the open source data. So for example, so we have the NYC open data. So if you check the data from the NYC open data portal, so you can see that they have the link which you can export and download them as a CSV or XML or JSON file. So if the download is straightforward, so we can use Google script with the trigger as the engine, and the Google spreadsheet as the storage, and the Tableau Public as the visualization tool. So in this way, we do everything on the cloud. So no more desktop or no more server inside. So everything is on the cloud, and you can just analyze the data, or you can write a script to analyze the data and process the data and pump the data to the Google spreadsheet. So that will be very, very good if the data is open to the public. So for more advanced analysis, for example, so you want to check the data with R or Python. So in this way, I recommend the AWS Lambda as the engine of the script, because AWS Lambda, they support to run the script uploaded by the user, and they only charge the whole process by the times of your script. So that will be a more advanced thing. So that solves the problem. So if the data is some kind of things like it's not easily to be processed, or they need a specific library like the pandas or some other library. So in this way, so the AWS Lambda will solve the problem and make the data automation serverless. And finally, I want to talk about why we recommend the serverless, because it's a scalable service and with affordable budget. So you can set up everything with less money. So you don't have to care about the server administration and the server maintenance. So that's a much more straightforward way for the researchers to do analysis based on cloud computing or based on a serverless. So that will be, I mean, the feature or the future of the research work. So yeah, that will be save a lot of money and make more performance. So finally, I want to talk about the lessons learned for building this dashboard. So first, let's talk about the drawbacks of the Tableau Public. So even though Tableau Public is really popular and they have a lot of good features, they still have some drawbacks. So let's talk about one by one. So the first one is about the dataset row number is only limited to 15 million. So that will limit the performance if you have a really large scale of data. So we experience the same situation. We have to truncate the data and reduce the size less than 15 million rows to make sure that the dashboard is visible. And the second one is like, if your storyboard is very complicated, so it's hard to maintain the layout, like the button or the navigation or the map. So they will crash, or the layout is disordered when you generate the storyboard. And also the responsive for the storyboard is not so good. So sometimes you feel like you build a very good storyboard on your desktop, and when you upload to the website, so for other people, they use maybe a larger screen or a smaller screen, so they will see a totally different layout rather than your desktop. So that's the problem for the responsive one. And also for the data sharing, they also have some problems. So if, let's say that the storyboard, it contains multiple panels or the multiple data resources. So when the user clicks the download button, so they will only get the first panel's data. So they will miss others. That means that even you make the data public, so they only get part of the data. So they cannot provide all the data. And we also have some experience about the loading speed for the embedded version. So when you share the dashboard by the embedded HTML script, so the loading speed is I won't say it's slow, but it's kind of have some delays, especially if you have several panels inside one web page. So they will largely slow down the loading speed of your whole web page. And also for the data access control, this like I talked before. So that's if you have multiple panels. So if you want only share some panels data and some others you want to make them private, it cannot be done. So either way, it's like you share all of them, or you make all of them private. So if there's no control, like you can share some panels and the other panels, they are private. So as a result, I mean, I have some tips for or some advice for the website developer. So we have 4 suggestions. The first one is to reduce the rows, or you add a filter like the time filter or other filter to reduce the data set to improve the performance. The other one is about we suggest to use the data sheet rather than the storyboard for a better responsive result. And the third one is we need to customize the embedded script. So the Tableau, they provide you the default script, which can be optimized by the developer. So we can optimize to make sure that the loading speed is affordable. And finally, so if let's say that you want to make sure that some panels, you want to share some panels data and some panels data keep private, so you need to build a navigation menu or a navigation index on the top of the Tableau panels. So in this way, so you can control them separately. So you can control the access for each panels in the Tableau, and then you build a navigation menu to lead the people to the specific page they want to download. So that will be the solution for the data access control. So that will be the whole lessons learned for the building this dashboard. So I will take it back to Jannie. So Jannie will show a live demo for the dashboard.
Thank you, Yubin. So I'm gonna go to our data dashboard, which I guess I need to refresh it. John, if you can maybe copy paste the links to the chat box. So if anyone is interested, you can actually play around with that by yourself.
Sure.
Okay. So basically, this is the home page of our data dashboard. I mean, I keep this page up for a long time, so I need to like refresh it. But usually it works well. And on the home page, what you will be able to see is we highlight some of the important metrics, like including this is the vehicle traffic, we have a citywide speed map, we have this MTA subway rider trends, corridor travel time, reported crashes. I mean, these can be changed and customized, but right now these 5 metrics we think is pretty important and it should be shown on the home page. So that just give you an overall an idea of how the vehicle traffic looks like, how the public transit looks like, and how the crashes and speed looks like in the city. And all the table and the maps are interactive. So if you hover your mouse, you'll be able to see some of the detailed information of each of these. And this board is not only serving as a visualization tool, it also serves as kind of data analytics. But then I'm going to enter the mobility board to show a little bit more details up here. So under the mobility board, these are the 2 sub-boards that are the most important part of our data dashboard, the mobility board and sociability board. Under the mobility board, we have multiple cities as tabs over here. And of course, New York City has more data. And when we separate that into different categories, so you will be able to see you will be able to find a particular data set by the category. And under each of these panel, for example, the vehicular traffic, there might be 1 or more tabs on the left to show you like different, like here it's showing us the bridge and tunnel volume changes. And this is only up to the last 3 months. If you go to the bottom and say that I want to actually see what happened in the last 8 months, including March, you can easily change over there and it will show you more data rows back to March. And we can also change to another chart over here on the traffic volume trend. The same here, you're able to change with the data range to see more data. Then go back. And this is the subway trend. On the top is the absolute value for like weekly data, and on the bottom is the percentage changes. So if you're interested in where the original data source comes from, we actually provide that information over here. So you can click on the link and it will lead you to, let's say for this one, subway ridership, it's actually extracted from MTA, where they provide the daily numbers and daily percentage change. But on the data dashboard, we kind of aggregate it onto a different resolution bi-weekly, so that it's just easy to see a long-term trend for that information. And this aggregated data is also downloadable. So if you click on this down arrow over here, you're able to download the data, or if you want to download the chart, you can also download as image. So everything is also open. Close it. Go back. And for the buses, besides the general ridership trends, we also provide a board called bus speed trend. So over here, this is within a lot more like data analytics. So besides just looking at the chart, if we want to see a particular bottle, we can actually uncheck this box and then see like I want to see booking. So this will give you the result for booking only. And also, if you want to filter this data by service type, you're able to do that for SBS selected bus service. Or I say like I'm interested in just one bus route, like my bus route, for example B1. Can click check B1, and this will give you information for only B1. Okay, just go back to home. And this is the city bike information. So again, besides the general trends of the city bike ridership, our student also create a city bike heat map that can help you to understand the spatial distribution of the city bike rides. And this is 2019 data by week. You'll be able to see the total rides. You will be able to, drag this bar to see different weeks. And the other thing is, if you want to compare with 2019 to 2020, can click on this go to 2020. It may take a while because the city bike data is a bit large. Yeah, okay. So it will take you to the same week over here for 2020. And then, by switching back and forth, you will be able to see, how the spatial distribution changed from 2020 to 2019. We also have this citywide speed map as shown on the homepage. And this one includes like different date filter that you can select different dates, or if you want to see a particular time of day, you can select different hours over here. This also has some animation. If you click on this fast forward button, so you see the changes over here, it's showing you an animation of the speed map by hour. So if you pick a specific day and you click on the animation button, it will show you how it changes in the 24 hours. Okay. And if you're interested in the detailed numbers, what miles per hour it is for each link, you can hover the mouse onto the link and it will be showing the number in the speed column. And we also have corridor travel time. This is for I-495, which is between Flush and Meadow, and goes through Queens Midtown Terminal and 34th Street in Manhattan and all the way to New Jersey Turnpike. So this kind of giving us some information of how the westbound and eastbound traffic went through the city. And same here, we're able to select for like different days. Let's say if we're interested in Monday, and we're also able to select, let's say if I'm only interested in the AM peak hour, 8 a.m., if I do 8 over here. So this will show you the trend on, Monday AM peak hour, like how the travel time looks like from March 1st all the way to, I think this is to September 22nd or 28th, something. Okay, let me go back. We also have some record basis data, like the reported crashes compared with 2020 to 2019 data. We create this pie chart, which showing you, in the most recent 2 months in 2020, how the percentage of crashes by injury type looks like. And over here, it's very easy to observe the cyclist injuries are occupy like more percentages in 2020 than 2019 over here. And these pie charts are updated every 2 weeks as well. Same for speeding tickets. These are the general trend for passenger speeding ticket, non-passenger. This is some preliminary data that we're also building a speeding ticket map to show you the distribution of the speeding ticket. And this is, as I said, from our test bed, the weighing motion station installed on BQE. So this tab basically provides some freight information. So we know that average daily traffic, but we also have like average daily traffic. Before and after for Queensbound and Staten Island bound, and also the speed information. I'm not going to these 2 tabs. Basically, these are the ridership or commuter rail accessible ride, taxi, as I showed in my presentation. We have all these charts for different like green taxi, yellow taxi, trip distance, durations, and also passenger counts. Under the Seattle panel, we basically have 3 locations for the volume and 1 location for the Interstate 5, but the Seattle panel is actually more for data analytics, especially for comparison. For example, over here, if we select a day, let's say we select a day before pandemic, February 24th, and we select a day during pandemic, let's say March 30th, okay.
Yeah. I think in the interest of just giving the participants the opportunity to ask questions, we can let them explore the last 2 or 3 on their own in the URL that I provided. And
definitely.
Yeah, so thank you so much for showing us this whole board. Thank you, Yubin, for talking through its development and maintenance. If anyone has any questions for our presenters, please feel free to add them to the Q&A, and I will read them out loud to the presenters. Looks like we have one already. It seems that there's a difference between trip distance and trip durations in terms of the trend, especially for yellow taxis. So this is around slide 13. Do you have a reason for this difference? So the difference between trip distance and trip duration trends for yellow taxis.
Yes, so trip duration is basically the travel time of a trip, and that is not only based on the physical distance among among the trip, but also it depends on the traffic conditions. So basically trip duration reflects a little bit more about, the traffic condition, like if it is congested on the road, if they are just traveling faster, for this particular area. And one thing that you probably know that because the yellow taxi and green taxi, they do have different territories. They can pick up passengers, they cannot pick up passengers. So this is also on one way, it's kind of like indicating a different congestion level, I would say, for the area that they travel. But this really depends on which area they're going to. That's why you see the difference. It's not the same. But trip distance is kind of like fixed, physical distance.
Is it possible to display real-time data on the Tableau dashboard? I guess like data that's dynamic, maybe?
I think there's no way to just make the real-time processing for the Tableau, because the mechanism is like they have to get the data first and then perform some kind of analysis. So I think they have some other tools on the market who support the real-time data analysis, but I think Tableau, they don't have the feature.
Right, that's one thing that I want to actually add, because that's a limitation of Tableau, but it's not a limitation of the dashboard. So, I mean, although it's showing offline right now on our dashboard, but if you go to Sociability Board or these like videos, we actually test it in real time, and it's possible to implement it in real time. It's just because right now we're still in a data agreement with New York City DOT on, getting the real-time access. That's why we are not showing like real-time monitor words, but that's the ultimate goal.
Okay. So I guess on that topic then, I was going to ask you how else this dashboard might be used after the pandemic.
It's actually, I think, yeah, I forgot the slides, but I do have a slides. We're going to continue updating everything that we have for the dashboard. And we're actually including, addition of new data, new matrix, and new visualizations. But the purpose is really we try to make everything automatic so that we don't have to worry about the maintenance so much, even, in the aftermath of the pandemic. And besides the impact of pandemic, I think after that, the dashboard can be served as kind of like monitor tool of the general traffic trend for the city, for like other impacts, maybe not only just from the pandemic, but it can be a long-term too.
I don't want to put you on the spot here, but are there any data sources in particular that you didn't use or didn't have access to that would have complemented some of this analysis?
I mean, of course, the answer is yes. There are a lot of data which is available, which might not be open data. But I think the goal here is we're trying to utilize as much open data as possible. That's as our first step. We actually include some of the aggregated, level information, such as the weighing motion station. It's not public available. But we think it's actually good to provide some data visualization. Maybe you're not able to download the data, but at least you can see, aggregated level of information. And we're also in like data agreement with many private companies and like other organizations, and hopefully we'll bring up all these data together in the future as well.
Okay, so I'm excited to have you back on maybe in a couple months or a year to talk about how the data dashboard has evolved. So if there are no more questions, thank you, Dr. Gao and Yubin. Our participants, you can visit the data dashboard website, which I've linked in the chat, to play around with the different interfaces. You can also rewatch this and all of our other webinars and seminars on the C2SMART YouTube channel. You can also feel free to follow us on Twitter. That's @C2SMART NYU. Thank you, everyone, for joining us today.